Hello Math 45 students, this is your instructor Cindy Enrique, and I'm going to pick up on section 6.3. So this section is all about logarithmic functions. So we have this definition. A logarithmic base b of a positive number x satisfies the following definition. For x is greater than 0, b is greater than 0, and b does not equal to 1. So y is equal to log base b of x is the same as saying b to the y power is equal to x. So it's really important to understand that these two are saying the exact same thing. So you can write a log in exponential form. You can write an exponential form as a log. So you can kind of say that the logs and exponents are inverses of each other. So logs and exponential functions are inverses. So that tells us that you can go and switch between each form depending on what your needs are. So down below, it says, write the following log expressions in exponential form. So what we specifically want to do is write them as an exponential. So first, let's identify some stuff. So that little number, oops, I don't want to do that. I wanted to highlight it. So this little number, we call that the base. So we can see that the base here is equal to 3. And we also want to identify the exponent. So the exponent is whatever it's equal to. So that's going to be my exponent. So I can say that my exponent is going to be 2. So what I end up having is I have a base 3 with an exponent of 2. And what does that equal? Well, that's equal to the thing inside the parentheses. So it's 3 squared is equal to 9, okay? So you always want to identify your base and you want to identify your exponent. So for part B, if I'm looking at this, I can see that my base is that little number, so that's 10. And my exponent is what it's equal to, so my exponent here is 6. So I can say that I have base 10 with an exponent of 6 is equal to the thing inside the parentheses, which is 1 million. Okay. Now for part C, the exact same process. You still want to identify your base. So your base here is 6. And your exponent. So your exponent is going to be 1/2. So when you rewrite this, you have your 6 to the exponent of 1/2. It's going to equal to what you have inside the parentheses. So here you don't have the parentheses, but the only thing that's left is that square root of 1/6. Or sorry, the square root of 6. Okay? And just as a reminder, we know that the square root of 6, this is really where you have a square root, so your index is 2. So when you rewrite this, this is 6 to the 1 over that index. So you can see that these are saying the same thing. Okay. So that is how we go from a logarithmic expression to exponential form. So we're just getting used to kind of going in between the two. So now we're going to do the opposite. So now we want to write the exponential equation as a log. So, okay, same thing here. So I'm going to go ahead and try to use the same colors here. So I know that my base is 2. I also know that my exponent is going to be 3. So this is what's going to be going inside my parentheses. So I'm going to have log base 2 and it's always going to be equal to my exponent. Okay, so what I put inside is going to be what I have inside the parentheses, which is going to be that 8. Okay, all right, so let's try that again. So I know that I have my base, that is 5. I also have my exponent, and that is my 2. So I know this is going to be inside my parentheses. So when I rewrite it, I'm going to have log, and here I have my base 5, and it's going to equal to my exponent. So what I'm going to put inside the parentheses is a 25. Okay, all right. So over here, I know that I have my base, that is 10. I also have my exponent, that's my exponent, and that looks like it's a -4. And what I'm going to have inside the parentheses is whatever it's equal to. So I'm going to rewrite this as log base 10 parentheses is equal to my exponent, and the exponent is equal to -4. So what I'm going to write inside the parentheses is that 1 over 10,000. Okay. And, you know, you can also rewrite this. Also, it would be correct if you were to write this as log 1 over 10,000 equal to -4. These two are the same. If the log is not specifically written, the base, then it defaults to base 10. So log is the same as log base 10. So it defaults, the base defaults to 10. All right, well, I hope that was helpful. We're going to keep going, moving on. So here it says, now you want to evaluate the following logarithms. So what might be helpful is maybe to review some of our rules of exponents. So for my rules of exponents, I think there's 2 that you really want to pay attention to. You want to remember that x to the m times x to the n is equal to x to the m plus n. And the second rule of exponents that you want to remember that whenever you have a negative exponent, we don't necessarily want to write it. So we just say we move it to the opposite side of the fraction. So we move it down, let's say if it was in the numerator, then we move it to the denominator. So, okay, so let's take a look at the first example. And I'm going to go ahead and just give myself some room to work it out. So here I know that let me see if I can keep the same color coding. Okay, so I know that my base is equal to 4. And my exponent is what I'm trying to figure out. So really what you're saying is, okay, so if I have base 4 and the exponent is, I don't know, but it's equal to that 64. So 4 to what power is equal to 64? And you're like, okay, well, let's try 4 squared. Well, 4 squared, 4 times 4 is 16. That doesn't quite work. So about 4 to the 3rd power. So 4 times 4 times 4. And that does give you 16. So I know that this answer is going to be 3. Okay. So now for the next one. I know here that my base is equal to a positive 3. And I'm trying to figure out what the exponent is supposed to be. So that's kind of what you're doing. So you're like, okay, so 3 to what power is going to equal this 1 over 27. Well, notice how it's a fraction. So this is kind of like going with rule number 2. Because it's a fraction, I know it's going to be negative. So since it's a fraction, must be negative exponent. Okay, so let's see if you can read that a little bit better. Okay, so if it's a negative exponent, let's try 3 to the negative 1. Well, that would give me 1/3. So that doesn't work. What about 3 to the negative 2? Well, that would give me 1/9. So what about 3 to the negative 3? 3 times 3 times 3, oh, that's 1 over 27. So now I know that my answer is going to be negative 3. Okay. All right. So now we're going to do it again for example number C. So for example number C, I have my base. My base is 7. And the exponent is what I'm trying to figure out. So I don't know what my exponent is. So I know that it's 7 to some power is equal to my 7. So what power would that be? So I know that 7 to the 1 power would give me 7. So here my answer is going to be 1. Okay. Well, I hope that helps you guys out, and we are going to continue moving forward. So here, our common logarithm, or our common log, that's the one with the base 10. So this is where I kind of mentioned before that if you don't specifically have a base, it defaults to base 10, okay? So it specifically says my log base 10, okay? And my natural log, that's going to be ln of x for my natural log. And that's corresponding to e. Do you guys remember e from our last lecture? So remember that e is an irrational number. So e is a number similar to pi. The reason e is similar to pi is because it's irrational. Just like pi, it's a decimal that doesn't repeat and never ends. So e is approximately 2.71828, and it keeps going forever and ever and ever, okay? And just in case you needed the reminder, pi is never ending, never repeating, and that's a 3.14159, and it keeps going on forever, never and ever, okay? So just know that both of those numbers are irrational. They're decimals that don't repeat, and they never end. All right, so ln is kind of the inverse of e, okay? So we are going to evaluate the following logarithms, and we're going to round to the 4 decimal places. So here you want to make sure that you put this into your calculator correctly. So the log button is right next to the 7 on the calculator. So on calc, log is next to the digit 7. Okay. So now you know where log is. So you press log and you type in 1000 and you just press enter and you get it to equal to 3. Okay. So this is just making sure you can put this into your calculator. Now for part B, I'm going to press that button log and I'm going to press 321 and I end up getting a decimal. So this decimal is going to be 2.5065050032. And it says round to the 4 decimal places. So 4 decimal places, 1, 2, 3, 4. So that's 4 decimal places. So that 0 is going to tell you what to do, whether you should round up or leave it alone. So since 0 is smaller than 5, I leave it alone. So I'm going to have my final answer as 2.5065 as my final answer. And the ln, the natural log, is right underneath the log button, okay? So ln is different. So if I press ln of 500, I'm also going to get a decimal. So ln of 500 I get is 6.214608098. And I'm going to round again to the 4 decimal places. So 1, 2, 3, 4. And again, I have 0 as the 5th digit, so that means to leave it alone. So I'm going to have my final answer as 6.2146, and that's the end of that. Okay, and that is actually the end of section 6.3. So 6.3 is really short and sweet, and it gets right to the point of converting the logarithmic expression into an exponential, and we have our natural log, which is ln, and knowing that it's going to be the inverse of e. All right, well, if you guys have any questions, please feel free to email me. Thank you.